Hi, welcome back to the video number 8. Today we're doing the next question in the list, which is the longest consecutive sequence. So this question is asking for a longest consecutive element sequence given an unsorted array of nums, and we need a linear algorithm. So for example, in here we have 104, 1, 2, 3, blah blah blah, and consecutive element sequence is 1, 2, and 3. Therefore, its length is 4. Okay. Same thing here. When we have nums, we are looking at this entire thing. This is not increasing, not increasing. Consecutive element sequence must be increasing. So 3, 7, 2, 5, 8. Okay. So we don't have to have the increase be 1. We just have to have it increase over the other one. So for example, in this case, we have 3 that is bigger than 0, 7 bigger than 3. This will be 3. Okay. And then from here, we are looking at 2, which is a drop off. And once this is a drop off, we can look for the next number, which is 2, 0. And this is 1, 2, 3. Again, it drops off again, right? So yeah, so again we look at here again, 4, 6, 0, 1. Hold on, what are we looking at? What is the question asking for? Consecutive element sequence, length of the consecutive element sequence. Okay, the longest consecutive element sequence. Okay, I think I misunderstood the question. Does not have to be in a row. It just has to be, in this case, we have to match up all the numbers that we have. So 1, 2, 3, 4. Okay. So again, we're looking at nums in this case. So obviously we have 0 to 8, I believe, which gives me back the number 9. So the question is, how can I find this, right? I'm looking at this, right? How can I find the consecutive longest consecutive element sequence, right? And then we have some restraints here, which is basically length of nums can be a very big number. The element within nums can be negative and can be positive. We are looking at the longest element subsequence, right? Okay, interesting. So just exploring a couple of ideas in my head now. We have this particular array here. What we can do is, whenever we have an array, array element, we can perhaps have a front and back for this element. For example, when we meet, right, visit 100, right? So the neighboring elements will be 100 and 101, 99, 101. So we hash this, right, into this, something like that. And then eventually, for example, if we reach 99 here, you can add 99 to this, and then 99 becomes a hash map itself, right? This is tough. 99 becomes 98 and 100. If 99 becomes is pointed towards 98 and 100, 100 is already previously visited, so yeah, this doesn't seem right. Initially I was thinking about sliding window, right? Sliding window solution here wouldn't work right? Because of it is unsorted. Yeah, it basically it's unsorted, so I wouldn't be able to run the window through the entire array. However, now we are looking at this element subsequence, right? And we're looking at this consecutive element sequence. Looking at this, and let's revisit this idea again, right? Let's say we have a massive hash map, right? For each value that we visit, we will queue the nums I value, right? And then when this happens, we will enqueue the neighbors, right? Let's put it like, what should be here? Let's try perhaps nums I plus -1 and nums I plus 1. Let's try something like this, right? And then when you come to 99 for the next digit, again, since this is num, nope, I can't see this because this is very hard to grasp. We need to have a nums I -1. Obviously, right? Okay, I think I'm a bit lost here, but let's just put this, right? Brute force with double for loop to form conseq sequences. So let's say, for example, you have a element that begins here, right? 100, and then you match 100 with 4, match 100 with 200, match 100 with 1. Once that's done, you realize there is no subsequence here. Match, match, match. Okay, 100 is the largest. Then you move I forward, right? J, and then you move J forward, and then once you're done, you come forward here, and you put I here, put J here, 4, right? You 4, you check with the rest, nothing. Nope, this doesn't work. No. How do I form 1, 2, 3, 4 at the end, right? Oh, okay. So you have I here, start J here, and then I here, and you start J here, right? And then you just form this. So essentially, we are forming I and J. We want to form we have I here in the second, we form J, no, we move along, J comes here, no, J comes here, no, J comes here, no. So this is a double for loop. Unfortunately, I don't think this is the solution, so let's go back to probably using a hash map. But in this case, let's say again, if you enqueue 100 as the key, right, and you have, for example, right, okay, how about forming the solution here, right? So nums I, we put it as a key. What we want to do, okay, essentially what we want to do here is to have sequence following nums I, right? Okay, cool. I think I got it. I think this might be a very promising solution. So we're looking at nums I first. So for every, let's conceptualize this element visited in the array, add it as a key, right? And then for the value of this key, we want to make it the sequence following the key, right? So in the end, this is something like how we're looking at. Okay, so for example, when we look at this particular solution here, looking at this, right, first thing first is we have 100 and we are looking at a sequence following 100. So we traverse through the entire array once, okay, we check the entire array, and then when we get to 4, okay, is 4, we have an array that is this, okay, we have a sequence map, and we have a neighbor map. Okay, so the sequence map and the neighbor map. The neighbor map here will be 101 to 104. Okay, let's just do it in increasing order. Forget about the neighbor map. Let's just say we have a sequence map. We come to 100, we visit 100, we enqueue 100 as a key. We visit 4, we will enqueue 4 as a key. And here, what we will do here is we put it as a empty array, and again 4 becomes an empty array. When we visit 4, when we visit 4 is 4 equals to 100 plus 1, false. Enter add 4 as key. So let's say if we have, say, second element is 101, right? Then this will become true. Then we want to add 101 to array value, right? Okay, makes sense. Great. So here 4 with empty array value. Again, neighbor map, we can remove it away. We have 104, 4 here, 100 here, and we have 200. Coming here, all the things go false, we enqueue it again. Here we come to 1, 1 becomes false, and then we have 1. 1 is false again, right? So 1 is false. We come to 3. 3 is false as well, and we come to 2. 2 becomes false. Right, so this linear way of running through this entire solution will not work. Will work if we have this, right? So so far we have traversed the array once, right, to populate the hash map. And since we have traversed the array once to populate a hash map, we need to operate. Now we want to operate within the array. So within the hash map. So we want to loop through the keys and check for neighbors. So for example, for key val in sequence map, we want to check if sequence map key, right? If this key, sequence map key plus 1 in sequence map, right? So for example, if key plus 1 in sequence map, what we want to do here is we want to add 100 to key, right? So we check here, this entire profile here, if key plus 1 is in sequence map, we want to add it. So we have sequence map key dot append key plus 1, right? Let's initialize this first for 200, 1, 3, 2. Go again, the next value here, we have this key value again. If key plus 1 is in sequence map, blah 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 blah, 4. Nope, 4 doesn't do anything, right? So here we go to 200. 200 is 200 plus 1 is in sequence map? No, right? For 1 is here's where things get interesting, right? So for 1 we have key value when key equals to 0, key equals to 1, right? When your key is equals to 1, your key plus 1 in sequence map, right? So if key plus 1 is in the sequence map here, which it is, in this case key 2, right? Is here. What we want to do here, okay, here's the interesting part, right? Append key plus 1, 2. No, here cannot be key plus 1, 2. Here what we want to do is we want to append all the neighbors that we previously found here. So we have key plus 1, key plus 1, right? Sequence map key plus 1. So we append the array. So in this case we have 1, we want to append 2, but let's say this was already 2 and 3, right? What we want to do is we want to append this entire thing here, not just 2. You get what I mean? So what we want to do here is we want to append the value instead, right? If key plus 1 is found, we want to concatenate the array values, right? Okay, so I believe in Python it's just a join, so we can do join here, right? So if key plus 1 here, we have sequence map key plus 1. Okay, so back to this case, we have this, and we want to have sequence map key join sequence map key plus 1. We join 2 to here. When we come to 3, right, we come to 3, Nope. Here we might need a recursive function, right? What do we need this recursive function for? We want to, because in this case, if we come to 1, right? If we come to 1, it will be 1, 2, and then we come to 3, nothing will happen because 3 and 4 will come here, right? And then we have 2, and then 2 will actually need 3. So 2 will be 2 and 3. And then we still don't have the best sequence here, because what we want to do ideally is we want to have 1, 2, 3, 4 here, right? This longest map here. And in this case, we need to have a recursive function. So let's just say, I think I know what, okay. If we have key 1, let's just remove this, right? If key plus 1 is in sequence map, what we want to do here again is to, before joining the value, we want to check whether or not this particular value, check if sequence map key plus 1 also exists, right? So it's kind of like a recursive function. I believe we have to do a bit of recursion here for this particular solution. I cannot think of anything else that is more appropriate for the moment. So yeah, in the interest of time, let's just straight away start to implement this and see what do we end up with. Okay, so let's just start up with this. Okay, and we have a solution, df thing, and then we have this. Let's just enter this. Okay, okay, we have this. Now we want to determine longer subsequence. Can we call this directly for key plus 1 in sequence map? Can we do a recursive function here? How would the recursive function work? Let's think. Double loop to form consecutive sequences, largest consecutive. If key plus 1 is in sequence map, for key value in sequence map, if key plus 1 is in sequence map, let's try to make this a recursive. Okay, so find neighbor, right? We have this, right? And then we have a map Nope. Nope. This doesn't work. I'm a bit lost. For key value in sequence map, key plus 1 in sequence map. Check if sequence map key plus 1 plus 1. Sequence map key dot join sequence map key plus 1. Let's go back to this example. We have this, and we are forming this entire thing to form the neighbors. And do we want to go through it again? Do we have to go through it again? Okay. So if we go through, go back to the example. Okay. We have 200, 1, 2, 1 UNQ 2, 3 UNQ 4, 2 UNQ 3, right? This is the end of the entire for loop. And then when you look at here, do you have the answer? You don't have your answer, but there is a way, right? Traverse the array once when we populate the hash map, right? Operate within the hash map. We want to concatenate the array values. We have this, right? So let's say we have this entire thing here, right? As the first sequence map. Result, right? Result after first loop of map. You have this, and what I want here is I want 1, 2, 3, 4, but I don't have 1, 2, 3, 4. I have 1 again, so I will have to go through the entire sequence again to form this. And this time, if I run myself through this algorithm again, where I just enqueue the immediate following digit after one digit itself, this wouldn't work because we have 1, 2, 3, 4, 1, 2, 3, 1, 2. Yep, nothing would happen because 4 is here, 3 is here, and then we enqueue it again, right? Nope. There's something I need to do here, right? There is something I want to do here. However, we cannot just concatenate the immediate following value. We also have to operate on that value. Remove this, remove this, remove this. For the value in this key, I'll make a sequence following the key, right? Sequence map 1, 2, 3, 4. We have this value here. Okay, how about the first loop? Initialize, right? So let's initialize this as like that first. So this is the original array, right? Original sequence map of the first loop. Right, and then we have this case here. For each value, we want to check the neighbor. Okay. I know. I get it. So the base consecutive, the base recursive function in this case, we are given a sequence map and we are given a index, right? So we are given an index and a sequence map. And here, what we want to do is we want to find if, right, index in sequence map, if index in sequence map value what do we want to do? What do we want to do? If the value plus 1, right? If the neighbor of this sequence map is here, we want to return sequence map value dot append we want to do this. Okay, the base case for this recursive function to find consecutive values, to find a value in the sequence map. So imagine this is passed into the array, right? The base case is if this doesn't have plus 1, doesn't matter, doesn't exist, right? So if value plus 1 does not exist in the sequence map, so if you come to 1, you come to 4, value plus 1 does not exist, right? We want to return, right? Obviously we want to return sequence map plus 1. Right, let's just take this. Return this. This is a bit of a indentation issue. Return this. And this. And let's just value plus 1 in sequence map. We want to find consecutive self sequence map. So find consecutive value sequence map. Okay, almost there. Okay, so let's just say this is pass sequence map is this value, right? And then we pass in find consecutive. We want to find consecutive here. Key value in sequence map. We want to find consecutive with the key, and then we want to have sequence map, right? So we definitely want to populate this entire array first, so let's just do that right away. Num in nums, right? We have sequence map equals to this, and then we want to do we can probably shortcut this. nums. How do we do this in Python? Let me do some googling again. Let's do this, and yep, I guess there's no short form for this, eh? There is no short form for this. Okay, I guess we can do this as well. Let me just num for nums. Okay, I should learn how to do this, man. Anyway, yep. We have this num and for nums and nums, right? So now we have sequence map. Okay. Once we have this for key value in sequence map, we want to find consecutive in key in sequence map, right? So let's say the first value here. Let's trace this algorithm. First thing first, we have sequence map that is here, right? Let's just move this down. We have this here, right? And then we want to find consec value 100. Let's just remove self, sequence map. It's like that, right? And then when you find consec 100 sequence map, you will immediately it will check, right? It will check for find consec 101, right? 101 here is not valid. Nothing happens. It's not. 101 does not exist in the sequence map. So since 101 does not exist in the sequence map, what we want to do here is we want to remove this 101 into 101 does not exist in the sequence map. Do nothing, right? Let's just remove this. Return none, right? Okay, so in this case, find consec doesn't really do anything. It just modifies, right? Returns nothing, but modifies sequence map in place. So here we have nothing. We want to do unit none. Okay, let's just put this here. What's the indentation issue here? Remove this, remove this. I guess we have this. Okay. Let's move this. Find consecutive. Okay, and then we will move on to this find consec. Return none. We will move forward to this value, right? In sequence map key, you will find consec 4. Right? Nothing happens. Absolutely nothing happens. And then you have 200 again, right? So again, nothing happens. The beauty here of what happens when you have it, when you have this come to 1, when you have find consecutive come to 1, right? We will want to have this, so value plus 1, right? Value plus 1 if 2 in sequence map, right? So 2 definitely is in sequence map here, which is true, right? We want to do find consec 2 sequence map. Okay. We have 2 here, find sequence map. Value plus 1 in sequence map, find 2 sequence map. Find consecutive self value plus 1 sequence map. And you find 2. 2 again will come in 3, 4, 5, 6, 7. 2 will return 3. 3 will return 4. And 4, we cannot return none here. We need to return something. In this case, we need to return nums dot append for nums dot append we want to do sequence map of value this is a bit of a headache. Let's find this. Find consecutive self value sequence map. Value plus 1 in the sequence map. We want to find 2. We want to find consecutive self value plus 1. What should my recursive function return? Right? When we reach 100, what should we return? Do we return the value itself? Do we return the value itself? Always a little bit iffy when it comes to recursion, but I suppose we have find consecutive if value plus 1 in sequence map, return find consecutive value map here, right? We just need this. We just need this find consecutive with value plus 1. Let's try this, okay? So the base case is we will return the sequence map value itself. And if the value plus 1 is there, what we want to return instead is actually to extend the array of this particular value. We want to modify this in place and extend this value with the consecutive one of the one inside, of the element inside. I know it sounds a little bit gibberish now, but let's run through the example again, okay? So we have find consecutive, looking at this, right? For consecutive 100, right? This simply does nothing and just returns this. Just returns this, right? Nothing happens, okay? Same thing, let's just remove this. Because value plus 1 in sequence map doesn't exist, right? And then we come to 4, value plus 1 sequence map doesn't exist, we will just return 4, right? 200, again, return 200. Here's where the fun comes in. We have 1, and then we want to come in here, right? We will call this actually essentially with 1, sequence map of 1 dot extend find consecutive, right? Find consecutive of this, right? So what does this give us? This particular value here gives us this, okay? This value here, we want to find 2 in sequence map. So what does 2 give us? 2 essentially calls this method sequence map 2 dot extend find consecutive. So this is 2, we'll find consecutive, and we'll find 3, right? And then this one will come in here, 3, we'll essentially get 3 dot extend find consecutive of self, find consecutive of self 4. Finally, find consecutive of 4 will give us the value that we want, right? This will give us 4, and then this value from 4 here will be returned here, right? 4, sequence map 3, extend 4, this value here will then return here, 3, 4, and then this value here again will return here to give us 2, 3, 4, 4, right? And then lastly, we have this particular beautiful value which comes into 1, 2, 3, 4, and we have this amazing longer subsequence. Okay, so this will essentially call all the values here, and it should be a linear time algorithm since we essentially construct this, right? So we construct this array, this map here, on time, And then, sorry, it's here. Here, we will essentially go through the entire array at most once, right? At most, we will call it at most another on time, because essentially it will chain the different consecutive sequences, chain, and at most another on time again. So this find consecutive, also on time, right? And once we have this beautiful on time value solution, we should be able to return sequence map value here. And then since we have this, and then we want to find, right, the longest subsequence in this longest array in this map. So we want to find the longest array in this map by looping through it, right? Let's just do some is this even longest consecutive? Why is this in camel case? Okay, never mind. Let's just loop through it one more time. With this entire array, we want to find a self sequence map, right? We want to do this, and then we have okay, let's just do this the traditional way. I was just googling whether or not there is a... We are finding the value sequence map dot items, and we are looping through these values, and if length of value is greater than max length, let's change this max length to max length is this key. Okay, run it. Okay, there seems to be an issue here. Find longest self sequence map. Yeah, guess there's some sort of Python 3 issue here. For this, let's run it. Like that, maybe. Self dot. This should be a value. This should be it. Come on, come on. Come on, we almost got it, man. Come on. We gotta return sequence map value dot extend self dot find consecutive value plus 1 and sequence map. What is the issue here? None type object is not iterable. What is this? What is this? Oh. Hmm. Oh, I'm not sure what's the problem here. We almost got it. We almost got it. We almost got it. 2, 3, 4, 3, 4, 4 is not a value. Oh shit. Oh man, we are supposed to return the length of the consecutive subsequence, not the... Ah, damn it. Okay. Right, am I right? I'm supposed to do this. 4. Seems to be some issues here with my answer. Case 1. Let's just print this out. I'm a little bit tired at this point. One, two, three, four, five, 6. We have 6 values here. So this sequence map should only call this 6 times. But why is this happening more often than not? Because of the recursion. Okay. So that's fine, right? We see that this is 3, 4. 2, 3, 4 is constructed here, right? And then we go back to this solution here. We have 1, 2, 3, 4 that is connected here. So we come up with this original sequence, nothing happens. Original sequence, nothing happens. Original sequence, 200, nothing happens. When we come to 1, 4, the third one is where something happens, right? So the third one, we come in here and then boom, have this call again. This call will extend and add 3 to 4. 2, 3, 4, and 1 we have 1, 2, 3, 4. And once we have 1 to 1, 2, 3, 4, we have one, two, 1, 2, 3, 4. Yeah, I will call the others as well. So this is the final one I have here. Why does this happen? The question is, why does this happen, right? Why does 2 append 4, append 4, append 4? 2, 3, 4. Something went wrong along the way. We have something went wrong along the way. Value plus 1. Yeah. Something went wrong along 3, 4, 4. 2, 3, 4. Damn it. Damn it. Something went wrong along the way. I guess it's after 1. When we come into 2 again, 2 will append 4 again. Huh. I think there's just a little bit of problem here, but more or less this will be my answer. I made a mistake here in iterating through this entire sequence because I essentially gave all of this I extended this. Let's try this. Let's do this instead, right? With some help from ChatGPT. We have this, we append this, and then we want to return this. And then we have this max length equals 0, blah blah blah. Let's try this again. Okay, I think instead of running a recursive sequence, yeah, I should have used the while loop. Yeah, I should have used the while loop to check, check the sequence. Okay, if I have a current plus 1 here, I want to increase my current, and then I want to append this to the sequence map. Once I have it done, I want to have the sequence map return this particular value return, right? And then this particular find consecutive is here. We will do it for every single one. We keep finding, keep appending, finding, appending, and once we're done, we can do this. Submit this. Hope this works. Damn it. Okay, I guess that will be all. I guess the general idea for this solution should be correct. I will study this question again and see if I've missed anything out. Thanks for watching.